Een beetje een kleine opkomst vandaag.
Ja, het gaat niet zo hard inderdaad.
We hadden wel dezelfde opkomst volgens mij op de meetup.
30 of zo.
Ja, 30. Toen hadden we dat de vorige keer ook.
Ja, dat is ook
Volgens mij zaten we de vorige keer ook al iets aan rond de 30 of 40 die alsnog kwam daar.
Ja, het valt een beetje. Het voelt een beetje laat.
Ja.
De meeste mensen gaan altijd kwart of 7
Als we moeten kijken of we de volgende later moeten doen.
Ja, misschien wel.
Gewoon een dag of.
Kijk.
Ja.
Het is aan mensen die zijn.
Je moet wel vragen dat mensen niet komen.
Dat is ook.
Maar kunnen we wel een poll maken op de meetup-pagina.
Het is gewoon starttijden of zo.
Starttijden,
of zo. Straks kunnen we er mensen allemaal voor die mensen bekijken.
Dat was ook vandaag inderdaad.
Ja, ik kan zelf pas van week achter dus geworden.
One guy who had pictures of dogs because he didn't like cats. There she is. I was just telling that I have pictures of cats in my home.
Dan zullen we even 10 minuten wachten dan. Zie je? Ja, zoiets. Je hebt Martijn gemaakt. Is het tussenuit gesnipt?
Ik zal het zeggen.
Yeah, I have like I follow him on Instagram.
Dus van, ik heb even niet op gemaakt, maar ik ga wel 2 weken van tevoren ga ik wel even naar Amerika toe. Dus ik ben niet te bereiken. Succes ermee.
Heb je nou in Amerika?
Nee, hij is zondag teruggekomen.
Ah, oké.
En een beetje last van zijn jetlag en heeft meteen vandaag moest hij nog jeugdteam trainen of zo. Al 2 weken achter elkaar is ingevallen. Kan hij net niet nog een week zeggen van ja, sorry. Er is iets tussen. Ja. Je bent ook terug net terug uit Amerika.
Ja, ik ben 2 weken geleden was me.
Ik ben er weer tijd om erheen te gaan.
Ja. Nee, ik in november of zo. Ik kan terug.
Ja, dan zaten wij weer aan te denken. Misschien nog aan die kant op te gaan.
Net vraag ik gewoon zeg maar even snel even heen weer te gaan.
Ja, de beste vlucht.
Ja, het kost je gewoon een paar dagen.
Yeah.
Als je gewoon de jetlag meerekent, dan
Yeah.
is nog bijna wel een week gewoon weer aan het herstellen van de jetlag.
Yeah. Hier de kibbeling, de herring.
Maar je hebt dus het grootste device lab in Europa?
Nee.
Niet? Net niet?
Nou, bij lange na niet.
Bij lange na niet?
Het grootste device lab is 2,5 keer zo groot. Ja, dat is echt. Wat ik heb is al.
Ja.
Zit nou rond de 200 devices?
Ja.
Niet allemaal nuttig hoor. Maar.
Een redelijk aantal.
Het is
Zou zo noemen.
de 3 grootste.
Ja.
En dat een dag.
Ja. Ja, ik wist het niet, ik woon zelf ook in Drachten. Ik zag het in de pijn en zei van, gewoon recht onder mijn neus. Ja.
Niet zo heel veel bezoekers hoor. Ik raak mezelf vooral heel veel.
Ja.
Dus, zo af en toe dan ga ik stop ik altijd een doos en dan ga ik er toe.
Nee, niet alles mee.
Ja, maar niet alles. Ik ben ook wel hier bij het ministerie van Onderwijs geweest voor een project dat ze dan op een bepaald moment een device nodig hebben.
Ja.
Oh, dat doet dat.
Ik gebruik hem vooral zelf voor het testen van apps die ik maak. Allemaal apps op basis van PhoneGap en dan gebruik je een webview en dan heb je nogal wat verschillen over de verschillende devices.
Ja, het is vooral Android.
Vooral Android.
Ik heb dit drama inderdaad gehoord.
Oh, wait.
Ik heb nu 75 Android-apparaten voor de webviews te testen.
Dat is echt absurd.
Ja, absoluut.
Ja.
Wat in Amsterdam was ook een PhoneGap conferentie, PhoneGap Day.
Ja.
En daar heb ik dus ook over de webview gesproken.
There he is.
En dan sta je op het podium en zeg je van 25 Android-apparaten.
So you first have to get the block, you have to wait for a while, and then you have to hit the...
It should not be like too fast.
Het zijn nog niet eens allemaal, dat is nog het allerergste.
Ja.
You can turn it off.
Dat is toch wel een heel groot nadeel van Android.
So in order to turn it on yourself, you have to do
Het is echt een hele grote fragmentatie van browsers en views en versies.
Het zou dan wel beter moeten worden nadat we Chrome voor Android hebben, maar nou ja. Samsung heeft gewoon standaard een eigen browser.
Ja, daarom ja. Je stelt er nog aan de manufacturer natuurlijk, wat je erop gooit. Ja, rommel.
Oh, bij mij. Dit is iedere keer zie je kanten, maar dan is het echt wel.
Dan kun je natuurlijk specifieke versie meelopen. Dat je wat minder
Ik had vorige week vrijdag nog een discussie met de maker van Crosswalk over het probleem van Android met verschillende webviews.
Ja, want het maakt het zelf niet.
Nee. Nou ja, Crosswalk die maakt gebruik van Chromium. Daar kan je je eigen versie mee leveren. Geweldig. Android 4 plus, binnenkort Android 4.1 plus. Dan vallen er altijd heel wat mensen. Ja, er worden nog steeds Android 2.3 apparaten verkocht. Echt een oplossing voor het probleem is er nog niet. Maar het wel
Really fun.
Je zit je al met een probleem.
Oh, did you do this?
Alleen maar is dat ook
ja, iOS is meer beheersbaar. Natuurlijk, je hebt wel verschillende versies. Daar zijn ook wel verschillen tussen, dat moet je optesten, maar sowieso heeft de meeste iOS-gebruikers de laatste versie. De tweede versie 6 op dit moment is geloof ik nog maar 1 of 2%. Dat is niet zo'n groot probleem als Android.
Nee, voor iOS bedoelt het namelijk voor ons ondersteuning. Dat ook niet.
Ja,
out of the box door je browser.
WebRTC op iOS, ja.
Hebben jullie daar een idee van geluiden?
Maar ja, iOS 9, nu zit het niet in. Zo zit het.
Het duurt nog eventjes.
Tesla heeft natuurlijk ook altijd weinig los. Dat gaan ze helemaal niet doen.
Ja, WebKit is een implementatie van WebRTC. Ze schreven door Ericsson. En er is ook een browser inderdaad, van Ericsson die WebRTC ondersteunt met de WebView van Apple. Hoe is dat precies gedaan, weet ik niet. Maar het is in ieder geval...
Het is mogelijk.
Het is mogelijk.
Ja, ik ben dan nu voornamelijk een plugin. Cadeau van plugin iOS FTC.
Ja.
Dat die Inaki die ook wat meer dingen doet in SIP.
Ja. Ja, inderdaad, daarmee krijg je inderdaad een PhoneGap applicatie kan je WebRTC gebruiken. Maar als je gewoon een webapp in Safari wil draaien, dan nou ja, ze doen geen tussentijdse updates van Safari, dus dat wordt minstens volgend jaar. Volgend jaar, september.
Heeft zo'n voordelen ook zijn nadelen, hè?
Het gaat wat minder snel op Safari, dus je hoeft minder te leren en zo.
Bijvoorbeeld.
Want Windows lijkt toch ook wel ook een eigen standaard.
Ja, je hebt Object-RTC wat Microsoft mee bezig is. Wat eigenlijk WebRTC 1.1 is uiteindelijk zal dat dan maar één standaard voor iedereen moeten groeien.
Als we niet allemaal reizen, een straatje proberen.
Ik weet dat in interne beelds van Microsoft daar al Object-RTC aanstaat. En ik weet dat het zal een tijdje VP8 ondersteuning hebben in interne beelds. En geloof ik dat dat sinds de komende Windows Insider build ook of VP8 ondersteuning, dat is al weer een stapje verder met praten tussen Chrome en Firefox.
Every time you probably tell the best person if you like the integration, it's also
Maar voor de rest kun je nog niet zoveel.
Deze stap is ik had onlangs een hele discussie met Christian Remon, die nou bij Microsoft werkt. En die zei van het komt. Het kan even duren, maar het komt. Dus ja. Maar waarschijnlijk zijn ze eerder dan Microsoft.
Ik hoop dat we daar uiteindelijk ook toch wel iets wel komen. Stel lekker. Voor de hele oplossing voor de iOS met die plugins, et cetera. Ja, is ik heb een native view die ze mogen natuurlijk view. Maar het geeft ook wat andere probleempjes in met Z-index en dat soort gedoe. Dus een beetje
ja. Nee, ik weet dat Apple iemand heeft zitten in een van de backend-engineers van Apple die is ook bezig met WebRTC. Tenminste, praten vooral. Waar code heb ik nog niet zien verschijnen.
Yeah, dude, that's crazy. Like I was just explaining capybara to him today, and I was like,
webkit gaan gebruiken of een eigen netwerkstack.
What? Ja, dat is altijd.
Well, it's 9 now.
Gaan we beginnen?
Ja.
Ja, wat?
Ik heb nog niks definitiefs gehoord.
Zelfs een livestream. Zelfs een livestream. Dit was een livestream. Ja.
Nee, we gaan thuis kunnen kijken.
Ja. 4 Martijn speelt. En die gewoon eens posten vandaag.
And then you
Hey everybody, thanks for joining our 6th meetup. There will have 2 speakers, one from HackerOne and Niels, who's going to start first. You want to introduce yourself, everybody?
My name is Niels. I'm the creator of HTML5 test, and I am a browser geek. HTML5 test, it's a website for testing web standards support. Basically, what you do is you visit the site of the browser, and it checks all kinds of APIs and features and what scores for each feature support. And it adds all those points up, and you get total score. And that total score is 555. Why 555? 555. It's HTML5 tests. The scores you get from HTML5 tests. Well, they are supposed to say something about how well your browser supports standards, but they're not that interesting to me, actually. But I'll show the scores from the current desktop browsers before I start with my actual talk. As you can see, Chrome leads with 521 points, and at the bottom is Internet Explorer 11. And as I said, the scores don't interest me that much, especially differences like this, because basically every browser that scores around 400 points is a good browser and perfectly capable of browsing today's web. What I find more interesting is things like this. Internet Explorer 6 versus Edge, and that shows that Microsoft actually has come a long way since IE6. So that's all about scores. My talk is about weird browsers. Weird browsers, what do I actually mean with weird browsers? Browsers and devices that do not adhere to current expectations. I have an example. 5 years ago, you had laptops and desktop computers, and you used mouse or trackpads. And you had phones, tablets, and used touchscreens. And you have events for both kinds of inputs. And if you check if a device has a touchscreen and use touch events, and otherwise use mouse events, well, 5 years ago that worked, but nowadays expectations have changed, and you can just connect a mouse to a tablet. And if you listen to just touch events on the tablet, this is not going to work. So that's what I mean with expectations. Devices that do not adhere to expectations. Weird browsers. Are there actually any weird browsers left? Because mobile used to be all about weird browsers, but mobile is the new standard, and everybody builds responsive websites, and mobile is actually not that interesting anymore. Where can we find weird browsers? Well, for example, game consoles, or portable game consoles. We have smart TVs, e-readers, smartwatches. Smartwatches can run browsers. Photo cameras, cars. This is a photo from a Tesla S, which has a browser in its console. Full touch screen with full browser. And well, I don't actually have a Tesla S in my device lab, so how do you test browsers like this? By the way, if there's anybody from Tesla here in the audience, come see me after. Well, all of these browsers have something in common. Comparable with mobile before the iPhone and Android. Everybody is just trying something, and not everybody is succeeding. So we have browsers with a high level of what the fuck. Well, we can't look at everything today, but I'll start with just smart TVs, set-top boxes and consoles, which I all treat the same because they're basically just big screen browsers. And testing big screen browsers is also difficult because I have a smart TV in my home, but I don't have a whole bunch of them. So how can I test if my website works on not just a WebOS television, but also Tizen television? Well, I went to the MediaMarkt. I asked them if I could test the browsers on their televisions, and they looked at me funny. It took some convincing, but finally they walked to a big drawer and handed me remotes, 5 remotes, and just said, go ahead. And I spent 2 afternoons at the MediaMarkt. And first of all, television browsers are actually pretty good. The last generation actually uses the same operating systems as mobile devices use, like Android or Firefox OS, Tizen or WebOS. And the scores on HTML5 tests are also pretty good. Not as good as desktop browsers, but still pretty good. Consoles are a bit lower. Basically, that's because consoles, the last generation is already a few years old. And you can see a clear division between this generation and last generation, which is 5 years old. I went to the MediaMarkt and I tried loading just a few demo sites, and this is what happened first. Low memory and slow CPUs. That's basically what televisions have today. And better than a couple of years ago, but it's still not optimal. So what are the big differences between television browsers and desktop browsers? First of all, control. Control is the biggest difference, and it's also one of the biggest problems. How do you navigate without a mouse, trackpad, or touchscreen? You use a D-pad, which is basically arrow keys. And well, that experience is not that good. You basically you press buttons up and down and move to the next button and press OK to activate the button. And it's comparable to feature phones or phones without touchscreens. The experience is pretty bad. But it can be worse. You could also just move a mouse pointer with arrow keys, and that doesn't work at all. There are a couple of alternatives. First of all, there's the analog controllers, especially on consoles. And an analog controller is a bit like that red eraser head on the middle of an IBM ThinkPad keyboard. It already works a bit better. And we have remote with trackpads. We have remotes with air mouses, which work a bit like a Wii remote, or a Wiimote. You point at the screen, and if you move your hand, the cursor on the screen moves, and that works pretty good, except your arm will probably fall off after 10 minutes of browsing. And we have second screens. This is the Wii U gamepad, and you have a screen in front of you. Well, that's very nice, but why bother watching on a TV if you already have a screen right in front of you? Well, perhaps it is to show somebody in the room what you're watching or what you're browsing. So, okay. Many manufacturers also make apps for controlling the smart TV or console. And again, why then not browse on the phone itself? This is for the Xbox and for the PlayStation, and this is for LG WebOS television. Another problem, or another difference, text input without using a keyboard. Once again, the D-pad. And it is very clumsy. This is how you enter text with a D-pad. You just go from letter to letter and enter the URL, which is very irritating for long URLs. Not that quick. Alternatives. Remotes with keyboards. And people used to laugh at the enormous full keyboard remotes for the Google TV and compared it with the simple and sleek and minimalistic D-pad of the Apple TV remote. But for text input, this is actually much, much better. And what many people don't know, you can actually connect USB or wireless USB to most TVs or consoles, and they just work. And sometimes you even have a trackpad built into the keyboard. It actually works pretty good. And once again, we have apps. The Xbox, the PlayStation, and many more. And another way of controlling the screen is gesture control. And actually, supposed to work really good, but I'm gonna, I recorded this earlier, I'm gonna try to do the same things I did here on screen.
High five.
Well, your arms will probably fall off after 5 minutes, and it really doesn't work. Okay, how can we control these inputs directly from JavaScript? We have mouse events, we have touch events, keyboard events. How about D-pad events or gamepad events? Might be useful for HTML games or something on the television. So, the D-pad, maybe. We can actually use keyboard events. And it most of the time it works, but there's still a big problem. Key codes, which determine which key you pressed, differ between manufacturer and sometimes even between model. So you can't just listen for the up key. On another television, it might be a completely different key code. And another tip is use prevent default, because most remotes have default functions that you don't want to use if you use your own events. But unfortunately, that does not work on every device. So expect pressing the up key and you get your events, but then the browser also uses its own handling of the up key. It's not really ideal. The gamepad, also a maybe. There's actually an API for listening to the gamepad. It's the gamepad API. And it's supported on the Xbox One, on the PlayStation 4, on the Wii U, on the WebOS, and Tizen probably. I couldn't check Tizen because they wouldn't let me connect the gamepad to the Tizen television at the MediaMarkt. So the SDK says it's supported, but so does PlayStation 4 and the Wii U and the WebOS. But while they say they support it, if you connect the gamepad, it actually does not return any connected gamepads. The gamepads array here is empty. Only the Xbox One actually reports back the connected gamepads. So the PlayStation, basically what the developers of the PlayStation did was enable a feature in their rendering engine, but didn't add any back-end support for talking to hardware. That's going to be the theme. The Wii U actually has its own API. Why bother using a standard? But it does work, so that's pretty good. The webcam, it's also a form of input, and we have an API for accessing the webcam. It's get user media, and it's only supported on the Xbox One. Well, not on the current Xbox One. Later this year, the Xbox One will get an update to Windows 10, and then Microsoft will support accessing the webcam. And gestures, well, no, but maybe in the future on the Xbox. I talked to somebody from Microsoft, and they alluded to looking at it, but there's no real clear plans. What are the differences between a television and a monitor? Well, the first thing is overscan. Due to historical reasons, the television will actually not show the borders of the image. It will enlarge the image a bit and crop it. If you have a built-in browser, it's not affected. But anything connected to HDMI is. So the television enlarges all the images from the HDMI input by 5%, and then chops off the borders, and that is the image you're looking at. And that also means that your beautiful 920 by 1080 pixel image will be enlarged a bit, and then you'll get blurry output. And that's clearly visible on the screen. So how do we deal with this? Well, there's a setting, it's called overscan correction. And most consoles allow you to change the overscan correction. And what it does is it uses extra black borders around the browser, around every image from the console. And when the image is enlarged, the black border will fall off, and the image is actually fully visible. That's a good solution, but still blurry. And not every television set enlarges the screen by exactly 5%. Can vary between different manufacturers, and even different models from the same manufacturer. There's a setting on most consoles that you can use to set the correct overscan for your system. There's always a problem also with overscan correction. The PlayStation 4 will always show the browser without overscan correction. So no matter what you do, even if you configure overscan correction on PlayStation 4, the sites will fall off. There's another solution. It's called no overscan. You can actually change the setting of your television and turn off overscan correction. And sometimes it's called screen fit or pixel perfect, or just scan. And if you don't use an English television, sometimes you get very weird translations, because the Dutch WebOS television, which uses just scan, I don't know if it has anything to do with overscan, but the just scan is translated to jetzt suchen in German. And I don't know why, but even just imagine, can your parents find this setting on their television set? And do they know what it does when it is jetzt suchen? Okay. Again, there's a problem, and ironically, it's again on the PlayStation. The PlayStation 3 always uses overscan correction. Because if you turned off overscan on your television, you will always get borders around the browser on the PlayStation 3. PlayStation 4 never uses overscan. PlayStation 3 always uses overscan. Okay. The viewport. There's a book created by PPK, Peter Paul Koch. It's called the Mobile Web Handbook, and it has a very good explanation of the viewport. I'll just quickly try to explain the concept of the two viewports. First of all, there's the visual viewport. It determines what part of the website is visible. And we have the layout viewport, and it determines how wide the site is rendered. And if you change the width of the layout viewport, you actually get a different rendering, at least if you use responsive design. There's the layout viewport and the the default viewport, the default layout viewport, is different on every smart TV, console, or set-top box. On mobile, it's usually between 980 pixels, and on desktop, it's the width of the browser window. But on the television set, it's between 890 and 20 pixels. So on different browsers on the television, your website will look completely different. It's possible to change the width of the layout viewport with the meta viewport tag, and that works perfectly on mobile. So instead of the default 980 pixels, you get the same layout viewport as your device, which most phone apps or web apps use, or you can set your own value. Works perfectly. Once again, problems. Meta viewport is not supported on television browsers. So there's no way you can get the same layout viewport in different television browsers. So what are you going to do now with your more beautiful responsive design website? There's another complication. Device pixel ratio is also not supported. And what you usually get on smaller layout viewports is that one CSS pixel consists of multiple device pixels. Just like an iPhone, which has a width of 320, the original iPhone, with 320 pixels, CSS pixels, but 640 device pixels. So each CSS pixel consists of 2 device pixels wide and 2 device pixels high. So each CSS pixel is actually 4 device pixels. So we want 2x or retina images. And that does not work on television browsers. So we have low resolution images. And how do these differences look like? I've created a couple of screenshots. This is the Nintendo Wii and the Wii U, WebOS, Google TV, Xbox 360, and things you can see things are getting smaller as the viewport width increases. Netcast, PlayStation 3, and PlayStation 4. So basically all over the place. One more thing. Device pixels are not always device pixels. Sometimes device pixels are not actual physical device pixels, but virtual device pixels. And for example, on Samsung 4K television or Panasonic 4K television, they render the content in regular HD and then upscale to 4K. And Samsung Android TVs render it in 720p and upscale to 1080p. And the Wii U resolution is the same as the little screen on the gamepad, which is then upscaled to HD. And the PlayStation TV, which is basically a PlayStation Vita without a screen and without the actual built-in controls. And it renders on the same resolution as the screen as the Vita. Another difference, distance to the screen. Make fonts and graphics on the site larger to account for viewing distance. People sit proportionally farther from TV than from a computer monitor of the same size. And that's really good advice. It's if you make websites that are supposed to be readable on television sets, you should make text and images 2 times or maybe even 3 times bigger. And how can we do that if we have all these different kinds of viewports? Well, the reverse of responsive design, fluid design, is basically the same layout on widely different viewports. The size of the content is determined by the width of the viewport, and we can use that pretty easily by using percentages for positioning. This works on small viewports and big viewports. It doesn't matter. 60% is the same width on a small viewport as on a wide viewport. And we can change the font size based on a fraction of the width of the screen. So text will automatically get bigger on larger viewports. And we could use viewport units, which are even better if they are supported, but there's a polyfill, so you're probably gonna need it. And of course, we need to make sure we have safe margins around the contents because we don't know how the user configured it overscan. There's actually some sites that use these principles and they work pretty good. One example is the YouTube TV website. And you can try it in your regular browser, youtube.com/TV, and it changes the layout completely for television. So how can we identify smart TVs? Because we want to give them special CSS. Well, we could use media types. Media TV. Should work, right? No. All televisions use the media type screen, just like regular browsers and mobile browsers. We could use the width and the height of the screen. Well, no. Like I said, there are many different viewports, so many different screen sizes. And many tablets or mobile phones or monitors also use HD resolution. So having a 1080p screen says nothing about the device you're using. You could use user agents, which is pretty bad, but also doesn't work. There's no universal tag in the user agent string which identifies it as a television. And this user agent string is a television browser. How do we know it? If just looking at the user agent string, it's Safari on Linux, which is already weird, from Korea. It's actually an LG Netcast television. So, what can we do? Well, go back 10 years or 5 years, make 2 different websites. Yeah. Or perhaps you can build a button that enables couch mode and sets a cookie or something like that. And if the cookie is detected, you add extra CSS for the television screen. And it is actually pretty handy because you can also use it on your laptop. And if you connect your laptop to a television, it also works. That's probably the best method right now. Number 4, be careful with feature detection. And basically every feature that talks to the operating system or hardware is suspect. It's something I said on my blog last week, talking about the problems with feature detection. And it is something that is really a theme with television browsers. You can't trust feature detection. And I'm going to give you an example, geolocation. This is simple code for geolocation. We have feature detect, detects the geolocation API, we have call the API, we have success callback, and we have failure callback. And we have alternative content. Well, forget about the alternative content. Just look at this piece of code. Pretty simple, right? What can go wrong? How many ways this can go wrong? Actually, 4 ways. First way is not that bad. The failure callback is called with a permission denied error code or location not found error code. It doesn't ask the user if it's permitted to use geolocation. No, it just fails immediately. Well, as long as it fails, right? We can handle this. This is actually on a PlayStation TV or an Xbox 360, on a Samsung television from 2014, LG Firefox OS television, all use this method of giving us locations. There's actually a far worse way of failing, and it's basically no callback at all. So the user just waits and waits and waits till a location is found, but never finds one. And that's something Sony Blu-ray player did with Opera devices and what my own web OS television from LG did. This is actually a problem, and we can handle this by setting a timeout and waiting 10 seconds before a location is found and then fail. Yeah, workaround. There are 2 more ways. First of all, success is called, but with longitude 0 and latitude 0, which Bison did and is not very helpful. But there's one more, and that one is almost comically broken. It's the Google TV set-top box, and it actually gave actual coordinates. Just the coordinates of Mountain View, California, near Google's headquarters, which also isn't very helpful. And this is just one example, and there are many more APIs. You get user media, get gamepad API, and many, many more. They're all problematic. So that's smart TVs. Yeah.
That's a question or
At the end. Yeah. Next topic. E-readers. E-readers have browsers. They score quite a bit lower on HTML5 tests. That's expected because they don't have video support and audio support, and so they have less lower score. That's okay, I guess. What are the differences between a regular browser? The infrared touchscreen, for example. We know capacitive touch, we know resistive touch, infrared touch. It actually works by a number of LEDs at one side of the screen and a number of sensors at the other end of the screen. And if you place your finger on the screen, the light ray is blocked and it knows where your finger is. Works. The resolution is quite a bit lower than capacitive touch because you have, for every pixel of resolution, you have to have a separate LED and a separate sensor. So perhaps if you move your finger on the screen, you won't be able to touch every pixel on the screen. 1 in 4, 1 in 6. But it works. And we actually support normal mouse events. Well, support is a big word because the Kindle and the Pocketbook, they support mouse events, but they coalesce them. If you press your finger down on the screen, it doesn't send an event. Once you release the finger, it sends both the mouse down and the mouse up at the same time. Okay. The Combo Glow actually works a bit better because they have actually separate mouse down, mouse up events. And if you move your finger, they actually send mouse move events. Very good. And Sony Reader is even better because it supports touch events. Well, touch events with one finger. But touch events, hey. But they don't sell the Sony browser, Sony Reader anymore, so we can forget about that one. We have just mouse events. And the e-ink screen, that's actually something that is also very important if you want to know about differences. Technology is pretty complex, but this is just a basic explanation. We have small microscopic balls with two-sided pigments. We have electrodes. And when we apply current to the electrodes, the balls will turn. And turn. So then we remove the current from the electrodes. The balls will stay in the same place. It's actually very good for battery life, but it's also very, very slow. And if you never used one before, you don't know how slow. It's phenomenally slow. I created a little video to demonstrate it. Yeah. So maybe those CSS animations and virtual screens weren't such a great idea after all. One other thing, colors that look very differently on a color screen can look pretty much the same on a 16 shades of gray black and white screen. They're basically the same. So how can we identify e-readers? Because we want to give them special CSS. We want to change colors, turn off animations. Monochrome CSS media query. No, it doesn't work. Basically, the browser thinks it uses color screen. The translation to black and white only happens in the display controller. So the browser does not know it has a black and white screen. User agent sniffing. There's no universal marker, but you can detect models, manufacturers, and that's pretty much the only thing we have. And finally, I want to talk about portable consoles. And there are basically two families: the Nintendo DS family and the Sony PlayStation family. I'm not going to talk about PlayStation because it's pretty boring. It's too normal. I'm going to talk about the DS family. It has two screens. And that sounds more complicated than it actually is because it's pretty normal. We have a dual visual viewport. And the bottom one is the primary. And it shows, it starts on the primary screen, and everything that is scrolled off the primary screen is shown on the secondary screen. And you only have touch control of the bottom screen. And don't try using the little pen on the top screen, that doesn't work. But it's actually pretty normal. And once again, I'm in the video. It just scrolls to the top, and that's it. Position fixed, it too works. Fixed to the bottom screen, but as soon as you scroll to the top screen, it moves to the top screen, and it's works pretty good. And what you may not know is these devices are actually being sold because of their internet browser. MediaMarkt had a campaign just a few months ago, and it said big on the advert, better browser. And how many of you use this as a browser? Perhaps we don't, but maybe teenagers. Because it's something to take into account. Well, are there any weird browsers left? Well, I think so, yes. There are many more, and perhaps I have time to talk about it some other time. But right now, I want to leave you with this quote. It's from Jason Bixby. We cannot predict future behavior from a current experience that sucks. And so there is some hope that the current experience pretty much sucks. Thank you. Okay, questions?
What is the browser in the Kobo? Just wondering the other day.
Sorry?
What is the browser in the Kobo? What engine?
The browser in the Kobo, it uses a WebKit rendering engine. It's pretty standard rendering engine. I even think it is based off the Android web view. Kobo is, I think it's just a shell around Android 2.2 or something. Okay. Yep.
Have you looked into voice in speech?
Yeah, I couldn't get it to work.
That's actually funny because you tweet yesterday, the day before, I think.
during the talk, Apple will probably announce a new Apple TV, which will make my talk outdated before it's over.
Yep.
And indeed, Siri in the new Apple TV, so you can talk to your TV.
It doesn't have a browser.
Can talk to the browsers.
There's both.
Yeah.
Can you do browser detection using the feature detection and the type of work?
Yeah. you can do that.
Yeah, because maybe you can do that and then combine it with also having the TV selector. I think we did something like that with EA6, right?
Yeah.
We detected some bug and then we said, well, if you behave properly, we will also work.
Yeah. But I have a whole lot of visitors on the HTML5 test website, and basically it does just that. It creates a profile of the browser, and from that profile, I can pretty much tell which browser we are using. So it is possible, but it's
It will also be
every day a new browser gets launched that is not known to our big database of browser profiles. So.
It will also mean that it will be hard for people at Google to use their geolocation. Like one time it's correct. So, do you think that like supporting every input device with a separate API is the way to go? Because it sounds like, to me it sounded it would be really scattered, like you have right now, that some browsers just decide to support some input devices.
Yeah, supporting, creating an API for every type of input. Well, sometimes different types of inputs can be mapped onto the same API. For example, remote controls and keyboards are pretty much the same. They could work with keyboard events, no problem.
The same with scrolling, right? Like you did with your gesture, like scroll the page.
They could translate that to mouse events.
Right.
Yeah. Probably better use a pointer events API, which supports mouse events and touch events and has hooks for other events. So it could probably get pushed into that. But right now there's no API at all. Yes.
Yeah, right. So but instead of like having a mouse API, wouldn't it make sense to have a scroll API?
A scroll API, I think they are working on something with, it's called Scroll Compositor or something like that.
Right.
And of course that works. But right now you could listen to the scroll events and use your gestures like that. But any more questions? Thank you.
So we have a few minutes for break and then we'll continue with the next talk.
Cool.
Yeah,
Pretty good talk.
Yeah.
Nou ja, dat doel is niet te ontmoedigen, maar alle dingen die je hier tegenkomt, kan je ook gewoon bij andere browsers. Niet exclusief voor televisiebrowsers, maar televisiebrowsers zijn wel heel erg. Ik loop een beetje achter. Volgens mij is het Philips met net TV. Oh ja, ja. Dan heb je waarschijnlijk een opera browser. Maar als er een browser op zit, dan is het waarschijnlijk een browser.
Durf het niet.
Ja, het is wat zuur en dit is
Maar ik ben altijd
Nou snel kijken wat Apple deed. Nou snel kijken wat Apple deed.
Ja.
Op televisiegebied. Kijken wat Apple aangekondigd heeft op televisiegebied. hebben een Apple TV aangekondigd, maar heeft hij een browser? Ja.
De oude Apple TV browser.
Nee. Hij heeft wel een webview.
Maar je mocht weer niet van de Apple Store voorraden dan een browser leveren?
Nee. Nou ja, je had nog niet in Apple Store. Echt een Apple Store. Maar je kon een alternatieve firmware installeren. Waar dus wel een browser in op zat. En die gebruikte dan gewoon standaard WebView. Maar gelijk een versie. Ik ben benieuwd wat ze.
Hou je nou ook iets bij met HTML5 testen van wat voor devices dan langskomen, wat voor scores zijn halen?
Ja.
Dat is juist het meest interessante, wat gekke dingen hier
van interne builds van toekomstige browsers. De nieuwste versie van Safari 9, die is sinds juni geloof ik, bij WWDC is die gepresenteerd. Ik zag al beelden voorbij komen die aan de baan.
Ja, dat is niet zo heel gek.
Nee, dat is niet zo heel gek. En nieuwe operating systems, Samsung Tizen telefoontjes die niet te koop zijn. Nog veel meer. Vorig jaar had ik een discussie met iemand van Google. Toen hadden ze even daarvoor hadden ze de nieuwe Chromium webview aangekondigd op Chrome Web Summit. En degene die dat presenteerde, met Grant, die was al van tevoren aan het testen. En ik zag telkens dingen voorbij komen van iets. Ik wist niet helemaal precies wat het was. Ik zag wel dat hij het deed. Want elke app op Android, die heeft een ID. Nog wat. En ik zag zijn naam in die ID staan.
En zo vind je privacy eigenlijk.
Ja, niet iedereen heeft zijn eigen baas.
Nee, dat scheelt.
Dat scheelt. Maar, dus ik zag dat voorbij komen. Ik zende een tweetje naar hem. En ik zie een browser voorbij komen. Is die van jou? Gewoon in het algemeen, niks verklappen of zo hoor. Maar,
nee, goed.
En toen werd dat opeens heel erg stil. Een uur later kreeg ik opeens een like van Paul Kinnan van Google. En geen reactie op de rest. En een paar maanden later sprak ik met iemand. Hij vertelde me van, ja, toen jij een tweet kreeg, toen jij die tweet stuurde, had ik opeens best wel wat probleempjes. Want toen moest ik opeens aan mijn baas uitleggen dat de nieuwe Chromium webview gelekt was. Maar die vond het niet zo erg. Dat zijn wel
was zijn
ja, dat was wel even.
Ja, het is wel even dat ze bereiken. Open zijn, de beurs genoteerd,
Nee, ik weet dat sommige makers van browsers gewoon beter aan de user agent meesturen. Gewoon zodat iemand achter kan gaan. En zelfs dan.
Jij eigenlijk wel zo kunnen detecteren, want je hebt anders scoren dan dat jij voor 95% van alle andere uren.
Juist, ik kan precies zien. Hey, die zegt dat die Safari 7 is, maar dat is hij echt niet. Dus het is grappig.
Ja, met de kopen had ik inderdaad thuis ook wel eens geprobeerd. Ik was vooral waarmee dus inputs op de code zetten.
Ja.
niet heel goed natuurlijk. Je toch denk ik stap klein. En zo storage.
Ja. Bijvoorbeeld ook de Kindle. Die heeft al 5, 6, 7 jaar gedaan. Die heeft steeds geëxperimenteerd. Ja.
Ja, dat is misschien goed.
Dat is misschien goed. Dat,
moet er niet aan denken dat mijn moeder denkt, zo'n ding. Ja, dat werkt allemaal niet best.
Mijn moeder heeft een keer geprobeerd en dat was heel snel. Ja. Er zijn een hoop hele vreemde browsers. En hopelijk wordt het allemaal wel beter. Maar kijk, wat ook heel veel fabrikanten doen, is die pakken gewoon een standaard rendering. WebKit, kijk al. En die hebben zelf geen verstand van die rendering. Die downloaden het gewoon, die zetten dat aan. En alsjeblieft een browser. En dan krijg je ja, inderdaad. En dan krijg je juist de problemen van geolocation. Dat browsers allemaal geen geolocation backend hebben. Dus maar wat terugsturen. Ik stel me voor dat dat gewoon geolocation backend was. Ze hadden geen andere. Dus laten we dat maar even inzetten op de test. Dat is nooit uitgehaald. Ja, dat doen we. Ondertussen. Nou ja. Nou ja, waarschijnlijk ook alle Google TV-gebruikers zitten hier met mouse en telefoon. Maar ja,
This is like really annoying. Yeah, it's really annoying.
Ja, dat zullen niet zo goed zijn. Maar er komen alleen maar weer devices. Dus standaard dan eigenlijk maar meer fouten op deze.
Is dan zitten.
ja. Ja, wel.
Okay. So how did the Apple presentation go?
They're not finished. They want to have a score?
Yes.
New iPad 2, new Apple TV, Apple Pencil.
Pencil?
Yeah, sliders.
What? Why?
Yeah, exactly.
They were also supposed to. They were also supposed to do a new iPhone.
Yeah, they're doing that now.
I can show you a new iPhone too. Cool. Is everybody here? Good to start? Okay. Well, hello everybody. Hello everybody. A couple months ago, Martijn asked me if I wanted to do a talk for GrunnJS. And I think I was a bit moody, and I think I just yelled 2 words at him: Karma, Webpack. So I want to start off with like actually changing the name, because like while like coming up with the whole presentation, I noticed that like just showing Karma and Webpack isn't really that helpful in my opinion. So instead, I'm going to call it testing modern day JavaScript applications. Oh, and by the way, this was my first explosion in Keynote. So I'm really.
I didn't see it. Do it again.
Do it again.
Yeah.
So yeah, this Keynote thing is a whole like it's great.
What's that browser?
So why do I want to talk about testing modern day JavaScript applications? Well, mainly because this is something we've been struggling at HackerOne. I've been working on the JavaScript test environment at HackerOne like for on and off for a couple of years now. And yeah, I think it was a good time now to talk about the things we noticed in our own code base and the things we're doing to make it better. First, let me start off with a little introduction. My name is Remon Oldenbeuving. This is my Twitter, this is my GitHub. I'm a software engineer at HackerOne. I've been working at HackerOne for almost 3 years now. Here's the proof. 2012. That's a long time ago. So that's me. Back to the talk. Testing modern day JavaScript applications. Last couple of weeks, I've been revamping our JS test setup because, like, we were noticing some big troubles with our own with our testing environment, and we were, you know, we wanted to fix them. So one day, I just, you know, like while writing my presentation, I said to myself, writing front-end tests should be as obvious as writing back-end tests. So, you know, I made it a quote, make it look fancy. I wanted to be, I was hoping to be the first one to do this tonight, but you already quoted yourself, so late now. But yeah, so couple of months, maybe like probably a year ago, year and a half ago, we kept on hearing this this term called Web 2.0. It's like really cool. So we were like, oh, maybe we should move more of our application to JavaScript. Right? So that's like, it's like way cooler because everybody's doing it. So we started doing just that. We moved to Backbone first, started moving pages to Backbone. Later, we did the same thing with React. So we moved our Backbone to React and moved more pages to React. But it wasn't long before we noticed the trend. So right here you see the console, the output of our backend test over here and our JavaScript test over here. And as you see, these numbers, they're like way off. Especially when you notice, when you see that these tests cover around 29,000 lines of code Ruby, and these tests cover around 20,000 lines of code CoffeeScript. So even though that's we like the ratio CoffeeScript Ruby is like 2/3, like this is like 1/10. So what happened? So, like immediately, let me start with saying that I'm not completely sure yet why this happened. Like, what's going on? Like, I have a couple of ideas in my head which I put here, but I'm still not sure if that's the whole problem. But okay, first off, it's harder to write good JavaScript tests. It feels like the JavaScript testing environment is like way younger, like the JavaScript testing culture. Which makes it hard. Another thing that makes it harder, in my opinion, is that like backend tests are really simple. They start at a point and they test for a return value. But with JavaScript, you actually have continuous interactions with your page, which makes it harder to test because you have like you want to do one interaction, then you want to do another interaction, then you want to see what happens. I think that that makes a difference. Another thing is culture, and this is culture in HackerOne. Like we noticed that every time you create a div and you change something in the backend, people are immediately wondering like, hey, where's the test? Did we change the test? Did we implement the new test? But for some reason, this didn't happen with the front end. Like people kept on changing things in the front end and kept on deleting tests in the back end, but the test didn't reappear in the front end. So that's a problem. Another problem is that at HackerOne, all our objects are stored on the global scope. So we don't use any modules. We store everything on window dot, which makes it really hard to scope out your test. Because like if you want to mock something, you have to like unmock it after running your test, because otherwise it will still be mocked in the following test. And this happened actually quite a lot, where we have like where you have like one test failing on the CI, but not failing locally, because like the CI is a Unix machine which runs the files in a different order, and there was one file that didn't unmock something, and everything breaks, and you like there goes another day. Another problem, it's slow. So if you look at the output of the test, we run around 5,000 Ruby specs in 6.5 minutes, and we run 500 JavaScript tests in 2 minutes. So it's not really like it's not that big of a problem. So that's why the question mark is there.
Is this because you have a DOM, or is if because JavaScript isn't slower than Ruby, right?
Yeah, I think it has to do with the DOM. It has to do with the like the implementation, like Phantom.js, which talks to a browser, which tries to be a browser. And I think it also has to do with our test runner in Rails, which I think there's some it's really slow for some reason. I don't know. So this was my feeling, like every time a regression happened in our JavaScript, this was the feeling I got. Like it would be really awesome if people could start writing tests. Especially like the last couple of weeks where we've been refactoring a major part of our application, and like with every refactor, another regression showed up. So something needs to change. But what? Well, first let me give you a bit of insight at where we're at right now at HackerOne, what the current testing environment looks like. So like I said, everything is defined on the window. We use Mocha, which is a testing framework to test our JavaScript. We use Synon to do spying / stubbing mocking, and we use Chai to do expectations. I think these three are like the most mainstream JavaScript testing frameworks out there right now. You could replace Mocha with QUnit, I think, or Jasmine, but like that's whatever you want. Next up, we use Teaspoon to run our JavaScript tests in a Rails environment. So this is where we are. Where do we want to go from here? What do we want to change? So personally, I really would love to use modules in our JavaScript, because this makes it really easy to find dependencies, to see which file depends on what other file, and it makes testing easier as well, in my opinion. Another thing I want to do is split away from Rails. Yeah, splitting from Rails. This is a bit of it's more of an opinion I have. That's not really. It's not that important. I think it's not an important of an issue. You can stay with Rails if you want to, but our JavaScript really doesn't need Rails. And like using Rails for a JavaScript environment makes it really slow, because like if you want to update a plugin, you have to update a gem, which updates a plugin, and it's all a bit harder if you use it in Rails. Plus, Rails startup time is just pretty slow. Another thing I would really love to do is sauce labs. So, like Niels showed, like every browser behaves differently, and that's why I would want to run our JavaScript tests in multiple browsers instead of only like one browser. Another great thing about modules is that it would make it easier for us to mock out dependencies. So because you know which component depends on other components, you can easily mock out those components in order for your test to stay nice and encapsulated. So what I did was like go see what the main options are out there, and just like start comparing them with each other. So if we look at modules, in my opinion, there are like two major module systems for JavaScript: Browserify and Webpack. Now again, let's all just forget the original name and start with the new name, which is Testing JavaScript, Modern JavaScript Apps. Browserify. The difference with Browserify and Webpack is that Browserify uses a more modular approach, which is funny because it's a module system. But basically, this means that for Browserify, in order for Browserify to work, you have to add a lot of plugins, and for everything you want, there's a Browserify plugin. Browserify is really popular, so like most of the times you'll find that the plugin is already there. Webpack, on the other hand, is different in that it tries to be like one big, giant thing that does everything you want. So Webpack has hot reloading, it has something to watch for changes, it has all the things you want. Plus, Webpack automatically supports bundling all assets. So you can actually depend on style sheets from your JavaScript files. I'm not really sure how happy I am with that. It sounds really funky. Great. Yeah, but on the other hand, like it makes sense for us because we use React, and React already defines the HTML in JavaScript. So I would say that like if you have like a nice clear component, it would make sense to just have that component depend on the style sheet of that component. But again, I'm not really sure if this is good. for now, I'm just going to leave it be, and maybe some point in the future I'll check it out. So let's just look at Browserify and Webpack and take an example: the mocking of modules, which I think is an important part of the of our wanted application. So by mocking modules, it's like you will have an easy way to scope out your tests. So you can actually say like, okay, this test is only about this module, and all the other modules can be mocked out. It could help with keeping the DOM of the test suite clean. This is actually really specific to our case. I think we have a component which renders something in the body, in the main body element. And what we notice is that like every time you run a test suite, like the whole body of the test suite is full with divs, which still have event handlers bound and stuff like that. So that's not really clean. So those kind of modules are the ones that you want to mock out, in my opinion. Where to stop with mocking your components in your test? This is actually a question I still have, and I'm still not sure what the right answer is here. Some JavaScript testing frameworks out there are called unit testing frameworks. Some are integration testing frameworks. Like Jest, Facebook's unit testing framework, automatically mocks every external dependency. I'm not sure if that's the way to go, because like with unit tests, it's really hard to say. Like you can have all your unit tests succeeding, but like if the two components don't communicate the way you think they communicate, it's still broken. So I'm not quite sure where to stop with with mocking out components. So for now, I'm just going to use it for cases like this, and cases where it would like really obfuscate my test suite if I wanted to render all components out. So how can you mock components in Browserify? There's a plugin called Proxy_Quirify. Like really, how do you come up with this name? The trend for Browserify plugins is to add ifi to the plugin name. But how do you come up with Proxy_Quire? I don't know. Well, I do know, but I'm not sure why you think it's good. So this is basically how you do. You have a component which requires link, and in your test file you require Proxy_Quire, Proxy_Quirify. You pass along the require method, and basically it overrides things in the require method so that it works differently. Following with that, you have like a list of stuff. So in this case, you say that link should actually do something else. So I just started with an empty function, but this can be anything you want. And then instead of requiring the proxy, the component in your test, you do a Proxy_Quire, and as a second argument, you pass along the stuff. This will make that like link will be the empty method in your test, and like outside of your test, it will just require the link. Same thing can be done for Webpack, but with a plugin called Rewire, like way better name, of course. With the only problem that that like Rewire and Require look a lot alike. So it's like really hard to notice in your code base like if something is rewired or not. And instead of like passing along the mocks, you can actually call .__set, and this will set that variable inside the scope. And Rewire is does a lot more than just setting. You can also get private variables from your component, like from that file. So it's a little bit more funky. It does something with eval in a really weird way, but it works. So, like looking back at like Webpack and Browserify, in my opinion, they both are like really equal. They're really much alike, and you can pick any one you like. I'm kind of biased because I started with Browserify for an open source project once, and I was running into some issues, and then out of nowhere someone came. I don't know, maybe he was working for Webpack, but he created a pull request and moved everything to Webpack, and he said now everything works. I landed the pull request, and I've been happy since. So since that moment, I've been using Webpack, and I'm still happy. Test runners. These are the 4 test runners I looked into. So basically, like JavaScript is pretty different than Ruby or like whatever I know in that case. That it's like in Ruby you have like RSpec and mini-test, and they're like the test runner, the test framework, the expectation framework. It's all the same thing. And with JavaScript, the test runner is a separate project. The test framework is a separate project. The exploitation library is sometimes a separate project. So test runners are just run tests in a certain environment. So these are the 4 I looked into: Zool, Mocha, Karma, and Jest. Start with Zool. Well, I think it's really funny that if you build like a test framework, that your build is failing. I looked into the test results to see why it was failing, and I didn't really see like there were a lot of lines that said things, but it didn't really make sense to me. So I think that's not really good. But other than that, Zool is really good. It's really it's really easy to set up, mainly because it tries to do a conventional configuration type of setup. So Zool comes out of the box with PhantomES, but you can also really easily run your tests in a separate browser on a separate service. The only problem for me with Zool is that it's like really young and the community is not that, like there are not that many people working on it. Mocha. Mocha is a test framework, like I said, we still use it, but it also comes with a CLI. So the CLI runs tests inside of Node.js. So in order to run browser tests in Mocha, you're required to run JS DOM, which is a fake browser implementation in Mocha.
Why you can Mocha in the browser? You can run
Yeah.
in the browser.
Yeah, you can also run Mocha in the browser, but you'll you can load it, right? You can create your own web page. So in order to make it a runner, you'll have to like install Mocha PhantomES, for instance, which needs a certain web page that you need to include. I looked into it. It is possible, but like that's the whole point of a runner. Like everything I'm doing there, that's the whole point of a runner. So that's why I stopped looking at some point. Because mainly, like the main thing we're trying to achieve here is that CI can run it, right? So that was where I got stuck. So yeah, the command line tool doesn't run on Sauce Labs. Like if you run the browser version, you can run it on Sauce Lab, of course. So just the CLI is a little bit.
You can also run the browser version in your PhantomJS. You can run the browser version in your PhantomJS.
Yeah, that's with the Mocha PhantomES. Right?
Yeah, so you don't actually have to depend on JS DOM to test your DOM and run your test.
Yeah, right. Yeah, no, that's So the JS DOM is purely needed if you want to run it in the Node environment. Yeah, the Mocha is compatible with running in browsers, obviously, because like all these other test runners that I tried, they support Mocha. So Karma supports Mocha. But like the main reason why I didn't do that was because I was looking for a test runner, and like with Mocha you can write your own test runner, of course. That's like that was like it would live in our own code base. Another thing, Karma is created by the Angular team, so it has a pretty strong community. Angular has a pretty strong community, and Karma as well. It's modular, like Browserify. So every plugin, like every feature of Karma that you want, it's in a plugin somewhere. And really, like every time I looked something up for Karma, right until this point, I could find like a working plugin for the feature I need. Then there's Jest. Jest is created by Facebook. It's used by React. It's used by Facebook as well. It does automatic mocking of external dependencies. So as long as you don't say that it shouldn't mock that dependency, it will automatically mock it. You have no choice in framework. So Jest comes with Jasmine fried in. The creator of Jest once said that he wanted to make it possible to use Mocha as well, but like I don't know, he's not really actively working on Jest. Jest runs tests in parallel because it also runs in a Node environment with JS DOM. So it's really fast, and it also really scales up well if you have like multiple CPU units. But you know, because it's a Node environment and it only runs on JS DOM, it has there's no support for Sauce Labs there. So that's all I surprised. I picked Karma and Webpack. So like I said, Webpack is really like you can pick whatever you want. If you want to go with Browserify, you should definitely go with Browserify. If you want to go with Webpack, stick with Webpack. If you want to go with require.js, you probably should just stop. I don't know. So what are the pros of using Karma and Webpack together? It's probably the most mainstream approach. This is like one of the first times that this happened to me, that I was like that the choice I made was actually probably the mainstream thing to do. Most of the times I find something that's like really, really exotic, and I'm like, yeah, man, that's what we need. This time it was pretty good. 2 powerful communities. A big con is that you either have to run all your tests all the time. So if you just want to run one test, you actually have to run all of them, or you have to create a separate bundle for every test that you run. But like creating a separate bundle for every test that you run, that's like really slow if you're like requiring React in every test that you run, for instance. Like every bundle will be really big. So we go with the first approach where we have like one big file which runs all tests. But I am pretty positive that I can find a way to fix that.
So you run all your testing in one DOM? Or do you refresh the?
No, I think the DOM is refreshed. I think Karma actually runs the test in iframes.
Yeah, exactly.
Yeah, but the main thing, the main problem is that like for instance with Mocha, you can say like I just want to run this test file, and with Karma Webpack you can't do that. I can show it in the demo why that won't work. Like maybe it's time for a demo. First off, like, are there any questions like until this point from the presentation, or suggestions, or?
Well, I was just wondering, why don't you split your unit testing and your sort of acceptance testing? I mean, you can run tests against all your JavaScript functions and do it in whatever, do it in Node, and don't have to deal with the DOM at all. And if you want to run acceptance tests, you can use WebDriver, Selenium,
right?
Direct that with whatever language or library you want.
Right.
And support source labs. I mean, it's WebDriver.
Yeah. So we do run acceptance tests. I think we have like 400 scenarios, cucumber scenarios running every change. But like I think I'm kind of biased here because when we started off with our Rails app, we wrote a lot of unit tests. And at some point we were like, okay, these unit tests, they don't make any sense. They're really fast, which is cool, but they don't really test anything. Like code still breaks. So we started moving to integration specs, which is like it tests more integration, but it's still not an acceptance test because an acceptance test is really slow. So I think I'm kind of looking for something similar for JavaScript, where I think that like really you doing unit tests in JavaScript is really fast, but not really helpful. But like testing all the features that we want to test in an acceptance test is too slow. So I'm looking in like if there's like a middle road somewhere. Yeah. So there are dedicated integration, like Angular has a dedicated integration test runner for JavaScript, which could be interesting. But I'm still thinking that we could pull it off with our current setup as well.
As you're testing React code, why don't you just run it all in Node against the fruit model?
So our components aren't written with server-side rendering kept in mind. So I'm not sure if that will work. The main problem I'll see right now is the supporting of AJAX calls. So, but also like I tried running our tests in JS-DOM on Node, and JS-DOM is pretty shitty. It's not shitty as in like it's bad, but it's like not fully feature complete.
You're really on the edge of what DOM can do with the React stuff.
Yeah.
So yeah, it's always going to be.
Yeah, but like the next version of React is going to be different because they're actually gonna separate the rendering. They're actually going to separate the rendering from the yeah. So like with the React Native and stuff kept in mind. Like the next version of React actually has like it won't render anything in JavaScript. It will just pretend like it renders something. So I'm not sure how that will work. But yeah, I'm not sure if that will work for us. like from what I've seen so far, it's like really hard to like you're running in all these kind of issues that don't really have to do anything with your app. It's not that you've broken something. It's just that like JS DOM doesn't do what you want it to do. Cool. I'll do a quick demo. I don't know what time. Yeah. So cool. So all these, like I created two packages for testing. One is the Coffee React Karma Webpack PhantomJS. I tried to put as much names in there as possible. The other is Coffee React Joule Webpack PhantomJS. So basically, it's like me trying to create an environment which looks a lot like our code base without actually doing it inside of our code base. So it's like, so we can just really quickly check if it would work in the ideal case. Where's my mouse? So when you start your Karma project and you run Karma in it, it will actually come up with a karma.conf file. Just a minute. This. Yeah. So here you see all the default stuff for Karma. So you say that Karma uses the frameworks Mocha, Chai, and Cinnamon, which like makes them magically available in your test. So up here you would have like a glob which finds all your test files. But because we're doing this with Webpack, we only link it to one file, which is the index.coffee. And up here we pretend that like there are multiple files, but basically this could have just read test index.coffee. And it tells the Karma to run the Webpack preprocessor for that file. Right here you see that we include the Webpack config, which we required in the top in our Karma file. And really there's just a basic reporter which reports your progress, and there's a JSON reporter which we need for our own tool set for our like our unit test reports in our dev environment. Well, the other stuff is just basic stuff. Right here you have a list of browsers. Right now we only have PhantomJS, but it's really easy to add Chrome here. Or if you want to use Sauce Labs, you can just create a separate browser for a Sauce Lab Chrome, for instance, and you can just put it here and everything will be run there. So that's the basic Karma input. Webpack is really simple to set up. So here you see all the things that we need in order for Coffee to work. One tip, if you're like working with Coffee, or if you're still working with JavaScript and you think like, oh, CoffeeScript, that's cool. Don't. Coffee JSX, that's like really a bad idea in my opinion. Because Coffee ASX depends on Coffee React, and Coffee React depends on Coffee React Transform, and Coffee React Transform depends on another, and like all their version numbers are way off, and like when like the end leaf end node upgrades, it takes a long while before you have all the changes. But you know what? We needed it, so we took it. Right here you say that you want to include Rewire in your test suite. Now let's go to the interesting stuff. So right here, this is the index coffee that we linked in the Karma file, and this is the only file that's being run in Karma all the times. And what you see here, this is some Webpack magic, where it's actually requiring all the files in the current directory which end with _spec. Yeah. It's like every time you look at this code, you're probably wondering what's it doing, but like this is it. The reason this was needed, the reason this is needed this way, is that Karma doesn't support like arguments, like command line arguments. So the reason, a way to fix this, to make it able to run only one test, would be to have a check here if like a command line argument is passed, and then only require that file instead of all the files. But like that's only something that's still in my head, built yet. So if we go to component spec, so I wrote one simple spec here. What you see here is that I require rewire. Like fun, rewire. I require the mock component method, which I abstracted, which like looks a bit prettier than the __set __. And basically here you say component is rewire source component, and then mock component link. So this is a method I made myself in order to make it work a bit more like we wanted to work in our own code base. And basically, this just has like one one empty React class, and then it overrides it with the underscore set, like I showed in the presentation. That's it. Oh, bind polyfills. Probably seen it a couple of times now. That's needed because FrontendJS in JavaScript still is FrontendJS 1.9, and 1.9 doesn't have support for the bind.
FrontendJS 2 works.
Yeah, FrontendJS 2 works, but FrontendJS 2 can't be installed through the npm package yet. Okay, that's nice. I'm still looking at an issue that says like there's a way to find the binary for 2.0, but that's not found on my computer for some reason.
No, I think you have to npm install FrontendJS 2.
Oh,
somebody else that package.
That sounds like a really good idea. Yeah. I'll definitely do that. So yeah, that's basically the main like how you set up Mocha, Karma, what else is in the name? Coffee, React, Webpack, and FrontendJS. So are there any questions on this demo? No questions. Then, oh wait, I have something. No questions. Oh, that's my presentation.
Nice screensaver, dude. Thanks a lot for coming, everybody. This was the 6th meetup. We're probably planning a next one somewhere in November, hopefully. We're still looking for more speakers, so if you want to speak at the next meetup, come see us, or just post something on the meetup page and grab a beer and talk. Thanks everybody.
Try to look out for spoilers in your talk next. With the Karma Webpack thing, that would just like ruin my whole talk.
Thanks, guys.
Cool. Oh, and there's one sticker left. One GrunnJS. This one? I think so.
Zo fout.
Ja, dat is een beetje culture, toch?
Nee, het is wel zelfversterkend effect. Op het moment dat iemand test schrijft, schrijven mensen een code die slecht testbaar. Als de codes hebben die slecht testbaar is, schrijven mensen in de test. Dus je ziet ook zoveel simulants. Wat bij ons, nou, dit het geval is, nou, je moet je even voorstellen, dit is het geval. Er zijn geen tests, de code is slecht testbaar, maar dan zijn er wel tests.
Oh ja.
Maar de testen echt zo.
Ja.
En soms zijn ze zo, zonder ene sleutel.
Ja, precies.
En in C-Sharp, in Unit heb je dan de fucking gruwelijke optie om een test is een method in C-Sharp, om die method parameters te geven en dan erboven te annoteren met tags met waardes voor die parameters. Dus mensen op het geniale idee gekomen dat je boolean parameters kan maken, bijvoorbeeld 16 boolean parameters.
Ja.
En alle permutaties van true en false wel even kan proberen. Je hebt geen idee met een test. Wat als een test stond. En dan, ja.
Oh ja. Maar dat is ook wat ik ook al zoveel bij ons zie met onze JavaScript code die getest wordt. Is zeg maar dat het duidelijk een test is die na het schrijven van de functionaliteit geschreven is. Dus die zegt gewoon, die test zeg maar, die test niet de functionaliteit, maar die test de implementatie.
Ja.
Dus die test van, je ziet hem if staan en dan gaat hij die if testen. In plaats van dat je zeg maar echt. Want als je dan vervolgens die if weggooit, dan heb je ook zoiets van ja, ik heb die if weggegooid, dus die if wordt getest. Het gaat nergens op, die gooit weg. Terwijl als het echt een case is, zeg maar, die getest wordt van ik verwacht dat dit gebeurt, dan is het eens van wacht, is het nodig? Ja,
client. Je bedoelt maar het heel niet. Logische keuze.
Ik ben ik zal bij de auto dat er een boete op zit. Mocht op 20 van 9 staan.
Oh ja. Zo moeilijk. Ja. Leuk jullie was. Doei. Maar ja, we hebben er naar gekeken.
Toen begonnen we met Webpack, toen was Ember nog spannend.
Ja, het was nog spannend. En we hebben daarna een keer aan HackerOne begonnen. En toen was Ember niet compliant met Untitled Chapter.